planets moved around it in perfect circles. Its theory was known as the heliocentric theory of planetary motion. Tycho Brahe had researched the motion of planets for over 20 years, but did not live long enough to analyze the data he had collected. Kepler consolidated Tycho's data to put forth his 3 laws of planetary motion. Kepler's first law, the law of orbits. Contrary to the popular belief, planets don't revolve in circular orbits around the Sun. They move in elliptical orbits. So, what is an ellipse? An ellipse can be drawn using 2 pushpins placed on a straight line. Using a string, when the pencil is rotated around the pushpins, ellipse is formed. Kepler's first law states that all planets move around the Sun in elliptical orbits with the Sun at one of the foci. Kepler's second law, the law of areas. Kepler's second law states that the line joining the Sun and planets sweeps out equal areas in equal intervals of time. For example, the area swept by the Earth in March and April equals the area swept in May and June. Kepler's third law, the law of periods. Kepler's third law is concerned with the time period of revolution of planets. It states that the square of the time period of revolution of a planet in its orbit is directly proportional to the cube of the semi-major axis of the elliptical path around the Sun. For a circular path, t square is proportional to the cube of the radius of the circular path. For example, for Mercury, the length of the semi-major axis is 0.39 astronomical units, and its time period around the Sun is 0.24 Earth years. For Mars, the length of semi-major axis is 1.524 astronomical units, and the time period of revolution around the Sun is 1.88 Earth years. Observe that the ratio of the square of the time period to the cube of the semi-major axis is almost the same for both the planets. Summary. Kepler's first law states that all planets move around the Sun in elliptical orbits, with the Sun at one of the foci, not at the center of orbit.